Greetings, my name is Nuradila Izzaty Binti Halim. I'm student of Faculty of Civil Engineering from UITM Shah Alam. Today I would like to present my paper on the effect of palm oil fuel ash as cement additives towards high-strength concrete. This is the presentation overview for today. Before I explain further, let me describe palm oil fuel ash. What is POFA? POFA is a byproduct produced from the combustion of palm oil husk and palm kernel shell in palm oil mill boiler. Many researchers have done studies on green concrete, which contribute to the uses of POFA. Results of their studies revealed that POFA contained a high amount of silicon dioxide in amorphous form and can use as pozzolanic materials to be utilized in concrete. This silicon dioxide content reacts with calcium hydroxide that comes from the hydration process and produces calcium silicate hydrate CSH gel compound, which improves the compressive strength of concrete. Firstly, the significance of my study is as follows. Let me discuss on what, how and why of my research about. What is the research about? My research highlights the potential of POFA as a cement additive towards high-strength concrete. How it be done? In this study, the POFA is used as addictive cement ranges from 0% to 15% to achieve the same or better result than the traditional concrete in terms of strength and workability in producing high-strength concrete. Why the research is done? Utilization of POFA is considered as environmental friendly additive to cement to produce a workable high-strength concrete. Next, let's go on to the problem statement of this study. The palm oil industry is one of the most important economies in Malaysia, and Malaysia is the world's second largest producer of the commodity after Indonesia. In December 2018, the Malaysian Palm Oil Board, MPOB, estimated the total oil palm plantation area in Malaysia covers about 5.849 million hectares. However, the massive production of palm oil annually contributes to a large amount of waste produced. The amount of total solid waste produced by the palm oil industry in Malaysia is about 10 million tons per year. POFA is the final product of burning palm fruit residues for the generation of electricity after the oil extraction process. The abundance of POFA is disposed of in landfills without any commercial value and gives a negative impact on the environment and other problems. Generally, the use of high-strength concrete has been utilized more in Malaysia nowadays due to its high durability and strength, which benefit more applications in the construction industry compared to normal strength concrete. High-strength concrete is beneficial since it can produce longer and lighter precast members and small-sized columns. Normally, high-strength concrete is achieved by a low water-cement ratio. To produce a consistent paste, a superplasticizer is added before adding fine and coarse aggregate. Then, supplementary cementing material is added to create additional strength by the pozzolanic reaction. Since POFA has pozzolanic properties, it is suitable to be used as a new supplementary cementing material in making high-strength concrete. So, this study on the utilization of POFA as an additive for cement in concrete may help resolve the landfill crisis, produce a good solution to the environmental issues and waste management crisis. In addition, it promotes environmental friendly practices and develops new green concrete innovations in the construction industry. Next, let's go on to the methodology of this study. This study highlighted the potential of POFA as an additive to cement in the concrete with different levels percentage of POFA at 5%, 10%, 15%. 4 different mixes were prepared, which is OPC, 5 POFA, 10 POFA, and 15 POFA. The effects of POFA as an additive to cement on concrete were investigated and were tested on fresh and hardened properties such as slump test and compressive strength test. All mix is tested on its fresh properties through slump test, and 3 identical cubes from each designated mix of 100 mm size were produced to evaluate its strength by performing a compressive strength test on days 3, 7, 14, and 28 age of testing, and the results were compared with those of control concrete. The relationship between slump test and compressive strength test is analyzed and discussed in result and analysis. Following are the results of this research. From Figure 1, it shows that the control OPC and the 5% POFA as addictive to cement, designated as 5 POFA, had the highest flow, followed by those of 10 POFA and 15 POFA. OPC and 5 POFA have a collapsed slump with a 240 mm slump height, while 10 POFA and 15 POFA have a true slump with 20 mm and 0 mm slump heights, respectively. Also, Figure 1 indicates that the workability of the concrete decreased as the amount of POFA in the concrete increased. In addition, Ahmed, 2008, in his studies, stated that as the amount of POFA replacing cement content increases, the workability of POFA concrete decreases significantly. The explanation for this is due to the existence of POFA, which contains a high volume of loss on ignition, which contributes to the absorption of more water, resulting in a decrease in concrete workability. Al-Sabari, 2016. Furthermore, the irregular form and porous composition of POFA absorbed more water, reducing the concrete's workability. Lim, 2013. Figure 2 shows the effect on the compressive strength for the concrete mix with the incorporation of POFA as addictive to cement at all ages studied, up to 28 days. 5 POFA has the highest compressive strength on day 3, 7 and 28. 10 POFA and 15 POFA seem to follow a similar pattern, with both having a slightly similar strength. It appears that the higher age corresponds to higher compressive strength. The increase in compressive strength may be attributed to podzolinich activity, Safiuddin, 2011. The high porosity of the POFA particles caused a decrease in compressive strength. Because of the properties of porous POFA particles, affecting the water absorption, hence increase the water-binder ratio in concrete, resulting in a lower compressive strength, Safiuddin, 2011. In Figure 3, by incorporating both the workability and compressive strength, a relationship between the two properties is identified to find the best mix of concrete. From Figure 3, 10 POFA and 15 POFA show to inhibit low workability. In terms of strength, 15 POFA and OPC show the lowest result in 28 days. Since the goal of this study is to obtain highest strength and workability, therefore the concrete mix that inhibits that property is 5 POFA. Next, this slideshow in summarize of all my main ideas in this studies. POFA in concrete tends to improve the strength performance of concrete, but at the same time reduces its workability. The strength of concrete with 5% POFA addition produces the highest strength, and the workability is as good as control concrete. Concrete with POFA addition more than 5% produces strength which is almost similar to control concrete, but lacks workability. All mixes produced in this study can be utilized depending on their application. If a more workable and minimal strength is required, the control concrete can be used. If a workable and high strength is needed, 5 POFA can use instead. On the other hand, if a less workable and comparable strength to the control concrete 10 POFA and 15 POFA can be utilized. In conclusion, the utilization of POFA as additive cement in concrete shows a reduction result in its workability up to 5% addictive. This is due to the nature of POFA that is porous. Besides, 5 POFA is the optimum percentage to be used as additive cement that will produce concrete with the best compressive strength. Thank you for your attention, and I really appreciate that you took the time to be here and listen to my presentation. If there are any questions, kindly contact me through my email in the slide. Thank you.